Good day everyone. So today I will be discussing the superposition of waves, qualitative and quantitative description. So first, what is the superposition of waves? The superposition of waves means that when two or more waves meet in the same place at the same time, they combine to form a new wave. For example, if two people make waves on opposite ends of a rope, when the waves meet, the rope moves higher if they add up or cancels out if they oppose. There are two ways to describe the superposition of waves, which are qualitatively and quantitatively. So when we say qualitatively, it describes what happens when two or more waves meet. It explains in words, no numbers. For example, when two ocean waves combine, it will form a bigger or smaller waves. When two people singing the same note, the louder the sound. And when we say quantitatively, it describes how much the wave changes when they combine. Explains using numbers, formulas, and measurements. This focuses on how big or small the resulting wave is. So in order for us to find the result of the resulting waves, we're going to use this formula. Y equals y1 plus y2. For example, wave A is equal to 2 cm and wave B is equal to 2 cm with the same pace. So tungod kay parehas sila og pace, ato na silang i-add and the result will be 4 cm. Another example is wave A is equal to 3 cm and wave B is equal to 3 cm. Opposite phase. So kay opposite man sila og phase, ato ni silang i-minus and the result will be 0. There are two types of wave interference. The first one is constructive interference. It happens when two waves meet in phase. Ang crease mag-meet sa other crease and ang through mag-meet sa other through. And the amplitudes add together creating a bigger wave. The effect is louder sound, brighter light, or stronger wave. The second one is destructive interference. It happens when two waves meet out of phase. Ang crease mag-meet sa through. And the amplitudes cancel each other out, making the wave smaller or disappear. And the effect or result is softer sound, dimmer light, or no wave at all. So here is a visual example of the waves. The first graph shows two separate waves. The second graph shows constructive interference, where the waves combine and create a bigger wave. The third graph shows destructive interference, where the waves cancel each other out. Here are some examples of constructive interference and destructive interference. So examples of constructive interference is concert speaker. When two speakers play the same sound in sync, the sound is louder. And radio waves when two waves meet and form a bigger wave. And here are some examples of destructive interference. Noise cancelling headphones. They produce opposite sound waves to cancel outside noise. Water ripples. Two waves meet in opposite phase, making the water flat at that point. Weak Wi-Fi spots. Signals overlap out of sync, causing poor connection. In conclusion, in qualitative, superposition explains how waves reinforce or cancel each other. In quantitative, it can be calculated using equations and amplitude relationships. Important in sound, light, and technology. That's it, everyone. Thank you for listening.